Hi, I'm Matt Dice from RioTech, and in this video, we're going to take a brief look at the RMD, or remote monitoring device. The RMD is a device with lots of capabilities for the rail industry, such as data aggregating and analyzing, data logging, remote reporting, and video recording. Here's a little background. We created the base platform back in 2017. We were doing remote monitoring of select locations in New York State. We integrated vital loops along crossing surfaces to detect vehicles which have turned onto the tracks. So we had, for these 3 tracks out here, loops installed right off the edge, and when GPS is saying turn right, people were pulling off of the crossing surface and bottoming out on the rails. So this was an alerting platform to inform whenever these events occurred. Later on during this site trial, we used cameras for trespassing detection. We used thermal, PTZ, and standard fixed cameras. Ever since this initial test bed, we've been tweaking and adding functionality to package the RMD into its current revision that it's in today. The RMD has integrated GPS, 2 Ethernet ports, 2 USB ports, a color touchscreen interface, a wide operating voltage. This is 9 to 36 volts DC through the use of an integrated isolated power supply. It supports up to 4 I/O cards, where each input card adds 12 isolated inputs, 4 of which support analog voltage monitoring, and each output card adds 8 vital class outputs, which are 12 volt sourced isolated outputs. The RMD is remote accessible and has internal voltage and temperature monitoring. It's also got 16 programmable LEDs to map inputs or statuses for quick indication. It also has an isolated RS-485 expansion port, which allows for any form of I/O or application expansion. We've used it to expand inputs when monitoring multiple loops installed onto roadways, and we've also given it support to grab quarter-second logs from HXPs. There was an issue with shunting on a light rail line, so we made the RMD communicate and constantly buffer the quarter-second logs. Then anytime that the MDR dropped, the RMD would store 2 minutes prior to the activation and 2 minutes after the recovery to give us our RX values for each train activation. This was an intuitive way for us to see what the track linearization looked like and could help determine when the rails needed grinding or scrubbing. We've also added VHLC communication support for the expansion port, so any changed variable states being pushed from a VHLC can be locally stored on the RMD. The RS-485 port also supports our soon-to-be-released DTMF platform. All of the I/O comes out of the rear side of the unit, and the RMD can be shelf-mounted or relay-mounted with the included double-wide relay-sized mounting bracket. Video recording. So the RMD supports up to 8 cameras. It allows pre-buffering to capture events preceding the triggering event of the recording. This particular video has 5 seconds pre-buffered before the activation of the crossing, but that value can be set up to 1 minute. The native storage on the RMD supports up to 80 hours of HD video in a high quality setting. You can get more time if you turn down the frames per second or lower the bit rate. But that being said too, at the 80 hours, the videos can be stored for just a selectable number of days or be stored until overwritten when more free space is needed. So the unit will delete the oldest videos to make room for new events coming in. It's even possible to offload video files via secure FTP to dump all videos to an offsite location. So as the RMD records each video file, it can load it securely to an offsite server if desired. Alarms. So the RMD supports up to 16 programmable alarms. Alarms can be activated according to inputs, health states or statuses, temperature, analog voltages, video detection, pretty much anything that the RMD touches. Alarms can run additional conditions such as pickup delay or drop delay timers on inputs. and can be further conditioned with inclusive or exclusive conditions, which will either be required to permit or prohibit the alarm from activating. These conditions really help to refine the activation of the alarms. For example, in this photo here, this was conditioned by the activation of the gate control circuit running a 15-second timer or so, and then if gate down was not received by the time that timer timed out, then the alarm would activate. And as we can see, we have got a trash truck hung up underneath the gate there. The content of the alarms is completely customizable. I've injected links to live cameras for some sites, and alarms can provide links to any flagged video files being recorded at the time while the alarm is active. So the alarm content can tell you the actual file that you're going to look at to view the video for when that alarm had triggered. Alarms can be used to trigger video recordings outside of the standard crossing activation. For example, video motion detection alarms. They aren't necessarily tied to the activation of the warning devices, but still something that you may wish to record. Active alarms can snap photos from connected cameras and email the photos as attachments. This helps to reduce the time to resolution where recipients can get a glimpse of the crossing whenever the alarm is active. A maintainer can know if a gate is broken before even heading to a site to troubleshoot. There's a lot of ease of life behind this functionality. This particular alarm activated from motion detection and came through and gave us quite the alarming glimpse that a child was playing around on the third rail insulator board out there. If GPS is connected and receiving valid data, then GPS coordinates will be included in the alarm with an embedded Google Maps link indicating which site the alarm has occurred at. The RMD has the ability to alert on recovery where it can inform if any active alarm has recovered, such as commercial power has been restored for a power out alarm, or a stuck crossing circuit has recovered. All right, let's move on to the demo and see the RMD in action here. So this is our RMD test rack. It's equipped with the RMD, a test box wired into a few inputs on the back of the RMD. It's got a screen to display what the RMD is displaying via a remote desktop. And then up top it's got two networked cameras that we've got installed. So kicking things off, let's test an alarm here. So I've got an input where whenever I de-energize it, it's going to activate our alarm, it's going to take two photos, and it's going to email them to me. So we can see here the RMD has reacted and tells me programmed alarms are active. I can even go and view that and it says, hey, my test alarm is active and has been active for 13 seconds. Well, I can go on ahead and recover that. And what we'll do is we'll expect to see the email come through. I pull out my phone. What do you know? I've got my email here. So it tells me my input 3 dropped like I have programmed on the unit for that alarm, and it included the two photos, one being the back of my head here. So moving on, let's drop another input here. This one can be used for power out. Well, this one's running an actual drop delay time. I set it for 10 seconds. It's not going to send any photos because there's not really anything worth seeing when you have a commercial power outage at a location. So it finally tells me, hey, the alarm is active. The input that you have wired for your POK has been dropped for 10 seconds, and I'm now active. We'll restore commercial power, and this particular alarm is set to re-alert as well on recovery. So now whenever I come and refresh on my phone here, I should expect to see two alerts, one being crossing power has been out for more than 10 seconds, and then I get the other one saying it recovered and the alarm was active for 17 seconds. So there's that benefit behind the alarming. Lastly would be, we'll go through input setup here. So whenever you're logging or analyzing or doing anything with the data, you've got lots of inputs coming in. You didn't know what they are and how they're going to react or be recorded. So whenever you set up the unit, you can set password protections behind the settings to make sure you can't get access to video data or any of the setup of the unit. But assuming that you've got proper credentials and can actually get inside the unit, you can come in and set up, configure your input card. I've got inputs 1 through 4 set up as XR, island, my alarm, and my power out indication. The same kind of goes for as you go through inputs 5 through 8, and then lastly 9 through 12 are the hybrid analog or digital style of inputs. So you can go and set up input 9 to either record as digital or record as analog. Give it a name, and if you have it set to record as analog, every 15 minutes it will timestamp and record the red analog voltage just every 15 minutes indefinitely. And you can even point to those voltages for voltage high or low thresholds for how you'd like to set that for any particular alarm. So once you have your inputs all named, you can then go and map them to statuses for the video recording, because trying to flag every input to be capable of recording video is just a little more difficult. So I've got it where you can actually go and map known statuses, point preamp to XR, island, gate up, gate down, and other customizable options as well behind this, and give the system known statuses. So if I go and I map an XR and an island, well then I will also get additional metrics in my log. Say my crossing activation warning time will now be logged, and then my island activation to not island activation will then give me my island occupancy time, so I can know how quickly that train got through the crossing. This being said, these statuses are then what you can map to or point to for your video recording. So I tell the unit to go in and record based off of XR and island here. XR activates, it tells me the unit's recording. I can see on LED 1 and 2, which is cameras 1 and 2 are validated as recording. I know that it's recording and it's saving that video. I can even wave at the cameras here and we can recover it. Now the big thing is, how can you get the data off of the unit? Well, there's different ways. You can, if the unit is networked, you can remote into it via the web browser and download from the file list that it's got there, log files and video files. You can FTP into the unit and access everything through that file transfer protocol. And then lastly, you can use a USB flash drive. The unit has got a USB options screen that allows you the ability to download the configuration, upload the configuration, download logs, alarms, and video files. So we'll go download that video file. Let's grab everything within the last hour here and hit download. Well, it found 2 files. It's got camera 1 and camera 2 from the activation I just did. Right here, it will now put them on my drive, and I've got access to them. Keep in mind that you will have to have the password entered in order to even get to that screen to download those, so you don't have to worry about anybody running off with the files. And then we'll navigate here, and we will see that I have got an actual video of me filming from whenever I tripped that activation. So this is just the easiest means to gain access to your data, your logs, everything. We're going to be at RSSI, the 2021 exhibit in Indianapolis. Come visit us at booth 510, and don't forget to check out our website at www.riotechnology.com. Thanks.